Alright everyone, part 2 of functions, drawing various functions and transformations on them. So these functions that I've listed below are some of the more important basic functions. Remember, we're ignoring all the trig functions at this point. We're going to handle them all together in a separate trig unit later. Okay, so these 8 functions are kind of the important ones for now. So let's start with the linear function. So the linear function y equals x, so that is the basic diagonal graph going through the origin. Oops, okay, I need the pen here. Okay, going through the origin, okay, just like that. Awesome. The quadratic graph, you remember, has a vertex at 0, 0 and flips up like so. Okay, the cubic graph kind of does this. Okay, there you go. Okay, the radical graph is just the top half of the parabola. Okay, like that. The absolute value, that's my favorite graph. That's the V graph. Okay, the reciprocal graph, that looks like this. 1 over x. Sorry, it goes through 1 and 1. Okay. That's not very good, so I'll try that again. Alright, remember the x-axis and the y-axis are asymptotes for these things. Okay, remember asymptotes you get really, really close to but never touch. Okay, that's great. Okay, the exponential graph, you'll remember the x-axis is an asymptote, and we go through 0, 1, and then up like so. Okay, and then the logarithm graph is the y-axis is the asymptote. We go through 1, 0, and then flip out this way. So if we know those basic shapes, then the next parts are going to be, well, quite a bit easier. All right, so to transform any of the previous graphs, we remember the general function equation. So that's this guy here. So y equals, so AF of B brackets x minus C bracket plus D. Okay, so remember A is the vertical stretch by a factor of A. If A is bigger than 0, okay. Wow, I did that wrong. Okay, when A is less than 0, there is a vertical reflection. Oops, that's kind of silly. Okay, A is less than 0, there's a vertical reflection, so remember that means it flips over the x-axis. Okay, B is the horizontal stretch by a factor of 1 over B. Okay, remember B is directly attached to the x. That's why we have to do the reciprocal of that. Okay, if B is, I did that here too, less than 0, then there's also a horizontal reflection, so a reflection in the y-axis. Okay, C is the horizontal translation. Okay, remember C is also attached or directly attached to the x, so that means we use the opposite sign or the opposite direction. Okay, and D is indirectly attached to the y, so just like the A, we leave it alone. Okay, if it's plus 2, we go 2 units up. That's so the same direction as the sign. So if we have a quick look at this guy here. Okay, examples. The graph of f of x is shown. Draw an accurate graph for the transformation of f of x. Okay, given as following. Okay, so y equals half f, okay, negative, blah, blah, blah. Okay, remember there's an order here. We always go SRT, so we do the stretches first, then any reflections, then translations. So this was a big unit in Math 30. Hopefully you remember. Okay, so first things first, stretches. So there's a stretch there. That's a vertical stretch by a half. So vertical stretch by a half. Okay, that means we take all the y coordinates and times them by a half. So this guy's y coordinate is 3, so he goes down to negative or positive 1.5. That guy's y coordinate is 0, so he stays there. They stay there. This guy, 1, 2, 3, 4, 5, so he goes 5 times a half is 2.5, so 1, 2.5. Okay, so there's our vertical stretch, and if I can just draw that now, whoops, Undo that. Okay, so we draw. So as you can see, that thing has just been squished. Kind of a terrible drawing, but that's okay. Next thing we notice is, okay, there's no negative here, there's no reflection there, but there is a reflection here, a negative. So that negative means we reflect over the y-axis, so it's a horizontal flip. Okay, well, all that means is that that point stays the same. This point is 1, 2, 3, 4, 5 away from the flip line or the mirror. So he's going to go to 1, 2, 3, 4, 5 on the other side. This guy, 1, 2, 3, so he's going to go 1, 2, 3 over here. Okay, sorry, is that 3? 1, sorry, pardon me, 2.5. That looked a little off. Okay, so 2.5, and again, just along the same line. So this guy is 2.5 down, but he's again the same 2.5 sideways, so he's there. Okay, so the horizontal flip makes it look like this. Okay, so that's the flip part. Okay, horizontal reflection over the y-axis. Okay, and then of course the 3 being directly attached to the x, that means we go 3 right and 4 up, and we're going to do that at the same time. So this guy here is going to go 1, 2, 3 up and, pardon me, 3 right and 4 up. So 1, 2, 3, 4, 1, 2, 3, that way. So that's going right there. This point here, same kind of thing. 1, 2, 3, 4, 1, 2, 3. This guy, 1, 2, 3, 4, 1, 2, 3. And then the last point, 1, 2, 3, 4, 1, 2, 3. Okay, and then our new function looks like that. Okay, so again, we do these things step by step. Okay, the stretches, then the reflections, then the translation, so SRT. All right, example 2. So draw the graph of this guy, okay, on the grid. All right, so tell you what, this one, it is helpful to start with the picture. The basic graph of this is y equals absolute x. So if we draw that one really quick, that is just the v graph, absolute value. Okay, so that's the basic graph. So let's see, I'll turn colors here. Let's draw on a red now. Now, hopefully that will show up, maybe not. Something bright, orange, awesome, that'll work. Okay, so again, same kind of thing. So we're going to do the stretches first. So I've got a vertical stretch by 2, a horizontal stretch by 3. Remember, the horizontal stretch is the reciprocal of that guy, so 3 over 1. Okay, horizontal stretch by 3. Oh, we've got a negative, so that is a vertical flip over the x-axis. Okay, and then we're going 2 right and 3 up. Wow, that's a lot to do here. Okay, so step by step. Okay, so we're going to do the vertical stretch by 2. That means taking all the y coordinates and doubling them. So this guy's y coordinate is 1, so he goes up to 2. Okay, 1 goes up to 2. Okay, this guy's y coordinate is 2, so he goes up to 4. This guy's y coordinate is 3, so he goes up to 6. 4, 6. Basically, they all double, so now we've got just a steeper V. Okay, so that's interesting. Then a horizontal stretch by 3. So we take all these x coordinates and multiply them by 3. So this guy is at 1, so he goes to 1, 2, 3. This guy is at 2, x is 2, so he goes to, well, times 3 is 6. 1, 2, 3, 4, 5, 6. Sorry, this guy was at 1, so 1, 2, 3. There we go, that's better. Oopsies. Okay, there we go. Alright, and then this guy's at 3, so he goes to 9, which is way over here. So 1, 2, 3. 1, 2, 3, 4, 5, 6. That one's at 9. Okay, so wow, it makes it a bunch wider again. Okay, so now remember we're on this graph here. Okay, alright, so that's the two stretches. Now we do the flip over the y-axis. Let's use a different color. Let's see if we can get a green to work. Okay, so this guy here, he's 2 over the x-axis. Now we're going to be 2 under the y-axis. This guy is 4 over, so now he's going to be 4 under. This guy was 6 over, now he is 6 under. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. So he was 2 away, so that was 1, 2, 3, 4. Sorry, he's supposed to be here. Wow, I'll get it right eventually. Okay, 1, 2, 3, there we go. Maybe. Sorry, I'll get the pen back. Wow, this one's great video. Alright, so then this guy, of course, vertex is still at 0, 0. Okay, so down to here. And now we're down to here. Now we're down to here. Alright, so there, it took us a while, but we got that one finally. Alright, awesome. Okay, then of course we go 2 right, 3 up. So 2 right, 1, 2, 1, 2, 3. So there's the new vertex. Okay, so all our points go 2 right, 3 up. So 1, 2, 1, 2, 3. Okay, this guy here, 1, 2, 1, 2, 3. So 1, 2, 1, 2, 3. Okay, this guy's going to be a little harder. 1, 2, 1, 2, 3. So there's that guy's pointing a little bit off the graph, not a problem. Okay, I've already done him. So this guy, 1, 2, 1, 2, 3. So he goes there. This one, 1, 2 right, 1, 2, 3 up. So our new graph looks like this. Okay, and I know it looks messy. Okay, but you know what? I'm gonna kind of squiggle over it, maybe make it the blue again. Okay, so and this. Okay, so that is the new graph. Okay, and again, we just went step by step by step. Okay, awesome. Okay, one more for this guy. So this one. This I'm going to draw on the basic graph here. So this is the reciprocal graph, y equaled 1 over x. Okay, so we have points there and asymptotes, and they just go woo. Okay, and kind of like that, and then down. Okay, a great sketch, but not terrible either. Okay, so we have points at 1, 1, and -1, -1. Alright, and then all this is doing, so that makes it go right 2 and up 3. So that includes kind of, even though where the asymptotes meet is not on the graph, it's still an important part of this graph. So that the point 0, 0 moves 2 to the right and 3 up as well. 1, 2 to the right, 1, 2, 3 up. Okay, and again, I'll just write in orange here. This is where the asymptotes cross. Okay, And because there's no other stretches or anything, like we did this graph on purpose because we don't transform this an awful lot, but thing is, it just moves the asymptotes. So now our graph itself, let's write in, it's kind of a reddy pink. Okay, so our asymptotes come down, and we're still kind of at 1, 1 just from that new origin point. So 1 up and 1 over. So again, 1 down and 1 over is that point. So we just kind of move in like this. Sorry, it looks like my graph goes down. It doesn't. It just skims along that asymptote line. Okay, so anyways, that kind of reddy pink graph, that is our new one. Okay, to absorb that for just a second, and this is the end of this part. Thanks, guys.